Okay, we continue. So, what is the mass? Problem 11 is asking you what is the mass number of gallium atom that has 38 neutrons in it. So, you look it up in your periodic table. Gallium has an atomic number of 31, which is the same number of your number of protons. The mass number is neutrons plus protons. So therefore, we can find the mass number of gallium. You are given 38 neutrons, and you found out that the number of protons is 31. 38 plus 31 is 69. Problem 12 is very similar, and it asks you, what is the mass number of a uranium atom that has 143 neutrons in it? Uranium has an atomic number of 92. It also equals to the number of your protons. So mass number equals to number of neutrons plus number of protons. You have your neutrons, you have your protons, therefore you can find the mass number of gallium, which is going to be 143 plus 92, therefore it's going to be equal to 235. Okay. Something more interesting. Now we'll talk about electrons. As you have learned, electrons are located in and outside of nuclei. And on page 122, the first question is asking you, what is the maximum number of electrons that can fit in an S subshell? Doesn't matter what shell the S shell is in it. Second question is a little bit confusing, but I'll explain to you. Every single S subshell can hold a maximum of 2 electrons. So as you have learned that energy levels like 1, 2, 3, 4, 5, and so on, all have S subshells. And all of those subshells can hold only 2 electrons. Remember, one S subshell has only 2 electrons. Second energy has 2s and 2p. So doesn't matter in what shell it is. Energy level shell is the same. It doesn't matter in what shell it is. It can only have 2 electrons, not more than 2. It can have 1 electron or it cannot have any of those, but it can have only up to 2 electrons. And it doesn't matter in which shell it is. It can be in the first, the second, the third, only can hold 2 electrons. So second question is absolutely the same, but now it's asking you about p subshell. As you know, p subshell can hold a maximum of 6 electrons. And no, it doesn't matter in what shell, this is p, is in. It can be in a second, right? Second subshell can have a p, second shell can have a p subshell. Third shell can have p subshell. Only first one doesn't have a p. First shell has only s subshell. And now it's asking you about d subshell, and d subshell can hold up to 2 electrons. It can have 1, it can have 2, it can have 3, but the maximum it can hold is 10 electrons. If it exceeds the 10 electrons, it moves on to the next shell. Okay, question 4 is asking you about F subshell, and F subshell can have 14 electrons, okay? And it cannot exceed more than 14 electrons. If it has more than 14 electrons, it has to move on to the next shell. Okay, so now something more specific. What is the electron configuration of a carbon atom? This is something that you have to learn, you have to memorize. How to fill up the electron configuration for specific elements. It depends what is the number of electrons the element has, and we know how to find the number of electrons. You have to look up at the atomic number. right? And usually they're given to you neutral. Neutral meaning that the number of electrons will be the same as the atomic number. So carbon has an atomic number of 6. Therefore, we can now fill up our subshells. So let's look. First shell, or energy level, has only S, and it can hold only two electrons. So first shell is finished. So we have 6. We need to fill up 4 more electrons. Let's start to fill up the second shell. Second shell has S and P subshells. S can have only 2. P can have up to 6. So 2s, 2 electrons, fill it up. 2p, only 2 electrons we need. So in blue, I showed you the total number of electrons of carbon. This is how you know how many electrons are there. 2 plus 2 plus 2 is equal to 6. So this is the electron configuration of a carbon atom. Okay. Over here I explained a little bit more, and for example you can read it. So let's look up sulfur. Sulfur has atomic number of 16, and it gets more complicated as you move along and the atomic number increases because now you have more shells to fill up. So sulfur has an atomic number of 16. So let's start to fill up our subshells. First one has 2. Second has S and P. We can fill up those, and this gives us 2 plus 2 plus 6, 10. So we need 6 more. So you start with the third energy level, and it goes. First is S, and then you need only 4 in your P. You don't need to fill up completely because you don't need 2 more electrons. So 2 plus 2 plus 6 plus 2 plus 4 equals to 16. This is the electron configuration of sulfur. Okay, next one. Question 7 is asking you about the valence shell electron configuration of a calcium atom. So first you need to do is look up what is the atomic number of calcium atom. So you found out that calcium has 20 electrons, right? Because the atomic number is 20, therefore it has 20 electrons. So valence shell electrons, or sometimes they're called valence electrons, are the electrons in the highest numbered shell. So remember, this is your first shell, this is your second shell, this is your third shell, and this is your last, fourth shell. So you are looking for the number of electrons in your last shell. In order to find out what's the number of valence electrons, you have to create a electron configuration first. You start to fill it up. First one has only 2, second has 8, third one has 8, and then fourth one has only 2. When you add up the numbers, you'll find out that it's 20 electrons. So the highest number shell is 4s, therefore over here. Therefore, calcium has 2 valence electrons. Okay, let's do more complicated example. It's asking for selenium, and it has 34 electrons. In order to create the electron configuration, you start to filling up the shells. First one has 2, second has 2, plus P has 6, then third one has 8, then 4s2, remember, then you skip 3d10. First goes 4s2, and then you write 3d10, and then you fill up the rest, you're adding up, and now you know that it has 4 more and a P in the fourth shell. So to find out the valence electrons, you need to add up these 2 subshells and their electrons. 4s2 has 2 and 4p4 has 4. Therefore, It has 6 valence electrons. Okay. What atom has the electron configuration? And it's given to you. Super easy. What you need to do is just to add up the number of electrons. 2 plus 2 plus 5 is equal to 9. Look for the atomic number of 9 in the periodic table, and your answer is fluorine. What atom has the electron configuration? 2 plus 2 plus 6 plus 2 plus 3 has number of electrons 15. And if you look up in your periodic table, you look for atomic number 15 and it's phosphorus. Make sure to not multiply 3 by 3 or 3 by 2. Only calculate these numbers. And that's it. A potassium, this is another question. A potassium atom has 18 core electrons and 1 valence electron. Okay, next question. Which elements have chemical properties similar to those of magnesium? This is something you have to look up and kind of memorize with the periodic table, because you cannot just, you need to do more examples of this in order to understand how everything works. So, chemical properties that are similar to those of magnesium, you're looking at the column, same column that magnesium is located. So any other element that is located in the same column as magnesium has the same chemical properties. So if you look it up, sodium is the first one, fluorine is in 17, calcium and barium are in the same column as magnesium, and selenium is in the middle. So only 2 of these are correct. Calcium and barium located in the same column as magnesium. Same type of a problem. Which elements have chemical properties similar to those of lithium? Lithium is in the first column, and you just look it up. What other elements are in the same column as lithium? Sodium and potassium. Next question, question is 3. Which elements have chemical properties similar to those of chlorine? Chlorine is in column 17 and is located right next to fluorine and iodide. Calcium is in column 2 and sodium is in column 1, and sulfur is in a different column, not close to them. Which elements have chemical properties similar to those of carbon? This is a tricky question because over here you'll need a periodic table and you have to know where other nonmetals, because carbon is a group that's called other nonmetals, and it's a little bit weird how it is in the periodic table, but the only other is oxygen. Silicon might be a possibility for the other answer, but it's not actually other nonmetal like carbon. Oxygen and carbon have more common. Okay. Which elements are alkali metals? You have to know this. This is the first column in your periodic table, and you just select the 2 correct ones, which are sodium and potassium. Which elements are alkaline earth metals? And this is your second column in periodic table, magnesium and calcium. Which elements are halogens? Column 17, which is fluorine, chlorine. Which elements are noble gases? And this is your last column, which is helium and neon. Which pairs of elements are located in the same period? Same period is not the column, but the line that goes across the period. And you can find out that hydrogen and helium are in the same period, same as sodium and sulfur are in the same.